Hello everyone, I'm Junjai from Rutgers. I'm going to present our paper, CPC. This work was done when I was a postdoc at Purdue. Code comments provide rich information which can be used to help perform various software engineering tasks such as bug detection. However, developers are less motivated to write comments, making it infeasible and error-prone to leverage comments to facilitate software engineering tasks. This inspires us to provide automation support in maintaining comments. As we know, program analysis techniques can be used to pass on information like data type based on program semantics. For example, in this Java code, we want to assign the value of y to x, then x and y must have the same data type. Inspired by this, we assume that we can propagate comments of the variable y to the variable x. So we treat comments as first-class objects and leverage program analysis to derive, refine, and propagate comments. With propagated comments, we can have additional semantic hints, and we can use such hints to enrich program analysis. For example, we can detect bugs by cross-checking code with propagated comments. In this way, we can achieve the goal of code comment co-analysis. This is a typical code comment co-analysis example. The class ArrayList has a comment saying that it permits non-elements. In line 1, the variable all is instantiated as a ArrayList instance, so we can propagate the comment to the instance all. In line 4, we visit each item stored in the instance all. The instance all permits non-elements. It means that the variable item here can be none. In line 5, when item is none, it will cause non-point access. So a non-point exception will be triggered. From this example, we can see that by propagation, we can pass comments to code that doesn't have existing comments, and with the semantics in the propagated comments, we can detect code bugs. It's well known that there are various kinds of comments, so now the question is whether we can propagate arbitrary comments using a unified rule. Let's look at an example. These two pieces of code are code clone. The method in C here has two comments. The first one is write a byte to the compressed output stream. This comment can be propagated to the method in figure A. The other comment is the method will block until the byte can be written. This one cannot be propagated. So here, the call E writes in line 8 of figure C uses the keyword synchronized here to block the method. By contrast, the call E writes in line 4 of the code in A doesn't have any synchronization mechanism, meaning that the method doesn't block, so the second comment cannot be propagated. From this example, we can see that even two code snippets are identical, we can't propagate all comments between them. Based on our study, the comments can be categorized into different groups. For example, the first comment here is actually describing the functionality, and the second one here describes the property. So before we perform the propagation, we have to construct a fine-grained and comprehensive taxonomy of comments. This table shows our comment taxonomy. We have two dimensions, code entity and content perspectives. Code entity means elements like classes and methods. Content perspective means functionalities, rationales, implementations, etc. Please read our paper for details. In order to construct the taxonomy, we perform a large-scale study of comments. Please read our paper for details of this process. After the taxonomy construction, we have 5,000 labeled comments. With these comments, we use 3 algorithms to train classifiers to automatically categorize a comment. The algorithms are decision tree, random forest, and convolutional neural network. This table shows the results. From this, we can tell that, on average, both precision and recall are more than 0.9, which means the classifiers are effective in classifying comments. Given a comment, we will first use the classifiers to get the corresponding code entity and content perspective. Then we can propagate the comment via program analysis techniques. Our propagation rules are derived from program semantics. They are certain and rigorous and generally applicable to all projects. As mentioned before, different code entities and different content perspectives require different propagation rules. Please read our paper for details of these rules. Now is the evaluation part. When we evaluated our approach on 5 projects, and the table here shows our propagation results. In total, around 41,000 new comments can be derived by propagation. To measure the effectiveness of propagating comments, we manually check the accuracy. When we say a propagated comment is accurate when it's consistent with source code. Based on the evaluation, our approach achieves 88% accuracy. To evaluate the usefulness of CPC in helping developers, we conducted a user study involving 14 users. To avoid bias, propagated comments and existing comments are mixed together, and the users are unaware of whether a comment is propagated or existing. For each comment, we measure 3 perspectives: meaningfulness, consistency, and naturalness. The figure here gives the comparison results, and it shows that our propagated comments align well with existing comments in terms of quality. This table shows the effectiveness in improving comments. Our approach can infer precise functional comments for 87 native methods that have no comments or code. Also, we detect 12 incomplete comments and 292 wrong comments. Some of them have already been confirmed and corrected. This table shows the effectiveness of our propagated comments in detecting bugs. In total, we detect and report 37 bugs, and 30 of them have been confirmed and fixed by developers. Here are some related works. Thank all the previous researchers. In conclusion, we constructed a comprehensive comment taxonomy from different perspectives with various granularity levels, and we achieve a seamless synergy of comment analysis and program analysis. Our artifact is available. Please follow the link to access it. Thank you for listening.